This is Algebra 1B section on mean absolute deviation, not terribly important, variance, and then also important is the standard deviation. We've talked about population and sample before. The population is the entire group that's being studied. The sample is just the smaller group of that population. And from the sample, we're going to get some statistics. And the statistics that we're interested in are the mean. We see this symbol with a little X with a little bar above it. Or we might see this symbol with this kind of fancy U. That's the Greek letter called mu. They're the same thing. And then we're looking for the standard deviation. A lot of times you're going to see this Greek letter sigma that looks like this. Sometimes we might use the letters SD for standard deviation. And we use a standard deviation if the data that we have looks normal. One of these bell-shaped curves. It's not always going to be a perfect normal. And we'll talk more about this bell-shaped curve in the next lesson. But the goal here today is to be able to calculate a standard deviation. We should already know how to calculate the mean. We've been doing that for a while. The mean absolute deviation really isn't in the scope of what we're looking at in this class. This is not a statistics class. It's just a statistics unit. And then this variance is going to be important. It's going to be the biggest step that we do to find the more important standard deviation. The standard deviation tells us on average how much do the terms vary from the mean or from the average. And that is an important thing for us to know as far as consistency goes. So jumping into this first example, first of all, find the mean of this set of data. 2 plus 4 plus 9 plus 5, add them together, divide by 4 because there's 4 terms, and our mean is equal to 5. There's step 1. Step 2, the variance. The variance requires a little bit more to do. We're going to take this mean that we just found, as well as all these numbers, we're going to subtract 2 minus 5 squared, and then 4 minus 5 squared, 9 minus 5 squared, and 5 minus 5 squared. So each of these numbers subtracts from the mean. We square them, and then we're going to divide by 4. Now, using your calculator, you can go piece by piece. 2 minus 5 squared, 4 minus 5 squared, 9 minus 5 squared, and 5 minus 5 squared. So I can go each one of those on my calculator or by hand, it doesn't matter. Then add all these up. So use your calculator, add all those up, divide by 4. And we get our variance. This is the longest step by far. The last thing we need to do to find this standard deviation is just take the square root of this. So my calculator, I take the square root of 6.5, and our standard deviation is 2.55. What this number means is that on average, each of these terms is different from the mean by this much. So this tells us how consistent these numbers are. We like small standard deviations if we're doing statistics because it means that our results are very consistent. All right, so number 2. Same idea. Find the mean, find the variance, and find the standard deviation. So step 1, can you calculate the mean? So add them all up. Divide by the number of terms. Once you have that, then to find, so this is our mean, standard deviation, 13 minus 17 squared, 17 minus 17 squared, 17 minus 17 squared. So I'm taking 13 minus 17, 17 minus 17, 17 minus 17, now 22 minus 17 squared, and 16 minus 17 squared, divided by 5 because there's 5 terms. So I'd go to my calculator, enter all of this in. or I could go step by step again. So 13 minus 17 squared. All those divide, we get 8.4 for the variance. And then take the square root of that. Square root of 8.5 comes out to 2.90. There's our standard deviation. So mean, variance to standard deviation. Go ahead and pause the video and see if you can calculate the mean, the variance, and the standard deviation for this one. You might want to verify that your mean is 47. If you didn't get that as your mean, then the other numbers will come off. Calculate your whole variance, 42.4. Then the square root of that is 6.51. So again, you can check with those. But that's how we're finding our mean, variance, and standard deviation in the set.